Okay, so the title is custom versus modular software development, and basically there's the idea. The question is when and should someone start just using third-party components, start using third-party software, and just somehow use it integrate it in the existing system, or when one is supposed to really start components, building new components fundamentally from the scratch, and really go in some completely new direction, and which is obviously quite often much harder. But there are some scenarios when you really or you really have to do that, or at least it's my humble opinion, it's much better to do in that direction. So the question is, at the very beginning, most of us at universities, even in schools, you've been taught about big O notations, about data structures, about algorithms, about all those nice and quite complex things. And in the end, it turned out that you have there are cool down when you become junior professional, that most of the time you don't know nothing about this. So you never talk about big O notation. You don't know nothing about data structure. Is something you put somewhere and it is there, and you don't have any. And the most of things you've been learned during your formal education is not used or barely used in the professional life. And one of the reasons for this is my opinion, is that somehow people in Europe, especially in Eastern Europe, has a bit colonial complex in a way that some serious software is getting developed something else, mostly in Silicon Valley or in the US, and then somehow we are just supposed to use that, to integrate that, and not to do smart development by yourself. And in the end, it turns out that you don't, and this is not wrong, but this is just the fact, that in the end you don't build your you don't build the software, you just somehow customize. You're just somehow customizing already existing solutions, and with some Turing complete configuration files, which is okay. Those that are Turing complete, which means that you can express yourself a bit more than you would otherwise. But nevertheless, most of the time you are just configuring existing tools instead of putting your added value in some higher level. And sometimes this is okay, sometimes this is the way how we are supposed to build software, but sometimes it's not. Since I'm a bit older than most of you are, things haven't been that while ago. And actually, you had a completely vice versa situation. So there was quite common these days that younger programmer, when I was a younger programmer, we were criticizing our bosses or our management that we are using a lot of niche, which means not invented here syndrome. This is when companies tend to develop their solutions from scratch completely. And of course, this is blindly, if you don't know what they're doing, this is by default, almost certainly this is wrong. And the industry is full of, and it will, I will see, but there's no need to talk about it this, because it's obviously that's wrong. But like in 80s and 90s, until somehow not internet as a technology, but as internet as a culture grew up that highly, it was companies really tend to implement most of things by themselves. Their implementation of string, their implementation of array, their implementation of vectorizers, everything by themselves. And of course, you had problems with standards, with bugs, with and younger people, younger generations somehow become completely aware of this, and this is good. But these days, actually, we have some completely different phenomena, and this is something I would like today to talk about. And this is this is not invented here anymore, but this is proudly found elsewhere. Syndrome, where people are really hard trying to reuse existing components at any price. And sometimes that price is simply too high, and sometimes newer generations, I would say, are somehow blind to some some obvious when some obvious necessity, and sometimes you really need to develop your custom component when you are simply you can't let yourself just to use existing technology or just reuse it and just somehow put it in a model. And I will go through some examples that I believe. Okay, so first, just a few. There's no need to talk about problems with not even here syndrome. It is absolutely obvious, like lack of standards, lack of full of bugs. You can't communicate with the rest of the world. So obviously, simply there's no need even to discuss about such fallacy in software development, because it is obvious. And now these days, everyone is aware of this. Back then, you would have some local guru who claims that he is able to understand how to build something, and people around him would blindly trust him, and that led industry in 90s to the place where really you had locally built the whole complete framework which barely works. Even in the early days of internet or web development, you had this lot of ad hoc web frameworks which were somehow coined by two friends in PHP would do something, and at the end, but how time has progressed, this simply doesn't exist anymore, because people started to use regular frameworks and mostly common use technologies for this. But nevertheless, there is also and this in the other end, there's still quite a lot of problem we have to address. First, this probably found elsewhere. Syndrome is most typically found in startups. Startups are extremely eager to build things as fast as possible. And there you always have a question, programmers are questioning each other, do we need to build that? Can we just reuse something? And really start putting things together as soon as possible, starting from using for existing components. While for some startups, this really could work. Today, I'm not sure that such startups have any, such startups will succeed. Simply because this is rather easy. So if you can put your application together out of existing components and put some glue, these Turing complete configuration files, the same what you can do could be done by someone else, probably in the same time. So and its real question is what added value do you put there? So so this is mistake which I found in few startups. I came as a CTO, and then it turned out that people are really having problems because existing technology which is used, which is simply doesn't fit to their problem, and instead of make the obvious, implement something by yourself, the people are still trying to reuse, to reading documentation, hiring some experts, which are at the end they are not experts at all, and simply avoiding to do something which is obvious. Implement that by yourself. This is your core business, so you have to do this. This is this other npm leftpad is just extreme example which I like a lot. This is leftpad is a trivial piece of software which just prepends spaces on the left of the string just to be right aligned, and at some point and this was npm package, like regular npm package, and people were so lazy. So instead of building their own leftpad function, they would, in how these days community is supposed to work, they would put that in their system. And then suddenly, the guy who implemented leftpad didn't want to re-sign some of the legal problem, some license problem about leftpad, and guy decided, okay, I don't want to make new license for my leftpad utility, whatever it is. And it turned out that half of the npm packages fell apart because they couldn't use this trivial part of software. So people don't blindly reuse just because it is cool and because our internet culture requires us to reuse. Of course, it is better to reuse, but not always. There is some cost, and especially there are some reasons where not supposed to do that. From my experience, from my point of view, I extracted 4. Those are not necessarily 4, but let's say I extracted 4 use cases where and this is from most likely to less likely. When you're supposed to go with your custom design, and where you are not to be, you should not claim that I proudly found elsewhere my component, but I really want to implement it by myself. First is that, and this is quite common. People will agree with me about DSL. Like domain-specific languages are probably the best way how you are supposed to develop your software. So this is well known. This is well known methodology how to develop your software from Common Lisp or Lisp dialects. These days, you can meet it in some form in Ruby or elsewhere. But but when you're doing a domain-specific language, its question is always first. Then you must know that somehow you are diverging from the rest of the community because now you are building something specific to your own needs, which means that you will handle your own bugs. But that's it. And but this is quite common. And I think most of people would agree about me that DSLs are supposed to be built in-house. And although these days you have also people like to reuse DSLs, but yeah, DSLs is quite common. I think we will have agreement on this. Then specialized algorithms. You will see, and this is, I'll talk about it later. I think I will have time. If you are doing something which is computationally problematic, and basically all low-hanging fruits, startups are already sold out, and you won't make another Facebook, you won't make another whatever. Now you have to do some hard computation, otherwise you won't get the money, you won't get the traction, you won't get anything. Simply, there's no just put something in the database, pull it out from the database, doesn't work anymore. You can do it for fun, but this is not such startup you won't sell ever. Simply, game over. These days, building software is complex again. It was always complex because you had this short period of time and it was rather simple to do it. But most of the time it is so complex it is supposed to be complex. And then you need to apply specialized algorithms. This is what when Rocco mentions building a database. Yes. So when you have some special requirements from the database, and if you want to apply it in custom in solutions which are out there, like use whatever out of stock databases, simply some problems won't fit. And not is only about database, it's about any high-speed calculations. If this is your core business, you have to do this. Third reason I listed about when you're supposed to do your custom design, your custom development is when you want to reduce dependencies. Dependencies are always somehow burden to handle. You have to install, you have to have it on build machine, you have to check up the versions if something went wrong in that third-party dependency, and of course, if such dependencies are really hard and something to depend on, of course you will use them. Out of the question. But sometimes you could help yourself by reducing dependencies as much as possible. Simply, sometimes, okay, like left pad problem. Okay, while guys could reuse npm package, which prepends spaces on the left of the string, it is sometimes better to implement it by yourself, and then because there's no problem about this and they are using dependencies. Regardless, you will have licensing problem or not. Simply, this is so that easy that there is somehow becomes bizarre if you want insist so hardly about third-party dependencies. At the end, which is these days everyone use ARM or Intel, but fortunately not everyone. So occasionally you will find exotic hardware, and then but that's okay. You implement it. Use use this. So it's not like if you find exotic hardware, you have two options. So run away with it, while hardware is quite good, or you will implement custom software fully from scratch for it. Of course, B solution is something what real programmers are supposed to do. My next slides will go through some examples I met in my career from simpler to harder, or not necessarily, which will somehow illustrate some of those motivations. For example, most of people are aware of this Lapak BLAS, this hard, extremely powerful linear algebra math tools, which are able to crunch matrices all around, and there's nothing wrong with those tools, except they are quite complicated. They are big, their dependencies are problematic. While you have a single interface implementation, it depends which implementation you are using. So it's not that easy to understand. But sometimes you have quite trivial problems, or maybe not that trivial, but maybe problems which could be, so by inertia, same as people are going to use third-party databases if you want to store some data. If you want to multiply some matrices, you are going to use Atlas or BLAS, or something like this, any of those hardcore linear algebra libraries. And in the end, it turns out that if you understand your tools, for example, GCC compiler, then if you understand how its internal optimization works, you could do it as an elementary school. For loop, just plain it for loop. Don't optimize it by yourself. Let compiler to do this, and then you will have vectorized code in the same way as Atlas will do. So if you have some elementary matrix operations, there's no need to bother yourself. There's no need to put some hard linear algebra packages for this. For some elementary operations, use elementary tools, and it will work excellent. The other example is example of quite exotic tool. So during my consultant career, I've been working for a company which has to work on, which has to put these chips in transmitters, and simply there was no way out. So there was the idea. So alternative would be to use some other DSP processors, which is impossible to deploy, and such processors were deployed all over the world, which means that you could transmitter in some desert in summer, and it's not very realistic that you can easily switch CPUs or the whole transmitter based on it. And alternative is to build a real-time OS for this custom chip. Of course, it's not a trivial task, but at the end, it turned out that after several months of work, and you can multiply by monthly salary, and you will see how it goes, you turn out with OS which could be applied and directly installed in existing transmissions in the world, which is something what you want. Following JavaScript compiler. This was something basically while my wife and me, we implemented this JavaScript compiler, but not as an idea to go with JavaScript compiler as a primary language. We had we developed something we call NAMOS, distributed peer-to-peer transactional system. It was completely written in Common Lisp. And in the end, it turned out that if you want people to use that, obviously people are not going to use Common Lisp that well. And then we started to build some domain-specific language on top of this. And then turned out that we're using some reader macros. We built a JavaScript compiler. And at the end, this JavaScript compiler had a bigger success than this little bit system. But its initial design was simply to use it as a third party, as a domain language for the system. And the most recent example I have now, this is where we stop, is TVBeat binary sectional list database. At the end, it turned out that when I came as a CTO or when I started working at the TVBeat, there was company already existed for some time, and they were building some we are collecting. It's not that it's on high volume. It's not very problematic in that respect. We are collecting the key presses on remote controllers, and then you are real-time analytics. And the problem is that we are dealing on daily basis with billions of events. Just this, nothing else. So like it's, and then you want to just do some real-time matrices. People from Split, which last week we've been watching something. What can you do some breakdown what they're doing right now? And now we have some not most, but some of European countries we already deal. And actually we have quite a lot of key presses. The team, which were our team, TVBeat team, initially started to use this Java cluster technology like Cassandra. At some point there was AVS, I don't know, Hadoop, whatever. And it turned out, and our competitors are still on Hadoop. And differences are so huge that I'm embarrassed even to talk about. We have a problem if our response time takes from 2 seconds, 5 seconds instead of a second or two. So we are now trying to retrieve pretty much real time, while competition on a single server. While competitors have I don't know, dozen of servers, Hadoop, and they will send you a mail in a week. So the only difference is that we decided to use custom tools. We decided to understand what L1, 2, and 3 caches mean. We decided to understand how TLB cache mechanism works. We decided to not just to blindly follow how industry is supposed to do that, but we decided to build our custom solution. It was C++ solution mostly. We understand how hardware works, or we hope, and we understand there are quite a problems. But nevertheless, then you create a new value. New value is that you are able to do that in real time, in a really tiny fraction of time for what our competitors needs. In the end, that will probably be interesting to you. We had this tech audit, occasionally, when you build startups, then you have some investors, we want to buy from you, but of course then you have a tech audit guys, which are supposed, by default, they need to be somehow malicious against you because they want to reduce your price just because they want to get a bigger share for the same money. So this is their job, to be somehow malicious. And first time when I was as a CTO, when I had to talk with tech audit guys, I was worried because everyone else is using Hadoop, Java, clusters, Amazon, whatever, and I built this custom solution in C++. I'm not using Amazon. I'm using Hertzner bare metal because of faster bus lines. And I was like worried. Whoa, the guy will probably tell me that it doesn't hold. And after 5 minutes, after the guy realized that we are using custom-built technology instead of then a guy realized, okay, this is the way how we like that you are going to build it, and he was actually he was satisfied, which means that basically it's not necessarily that if you are going contra direction that some people in the industry will really actually recognize what you want to build, and you could have really nice results. So this was really a short talk just about motivations. If you have some dilemmas or whatever, ask me or now or later. But in this time slots, I couldn't talk much more about details. So questions? Mm-hmm. But no, but you know this Knut's constant that 95% of time you are spending just in 5% of code, and vice versa. Which means that yes, tight loop will be implemented, having cache line in mind, having C++ or C, depends. But this is just 5% of code. So if you ask me directly, we are sitting on top of the Unix, so we didn't build our system on top of the Java JVM, which means that we have tons of short-living processes in the passage. We are quite close to POSIX semantics, which means that as a scripting language we use Lua, which is, by the way, quite performant, which means that for most of things you could use Lua logit exclusively, and only occasionally when you really have a need you go to C++ or native. Thank you.